Hi, I'm Gabe. For this problem, we're given two vectors, u and v, and we're asked to determine whether they are orthogonal, parallel, or neither. So let's begin by trying to determine if these two vectors are orthogonal. Now the way we're going to do this is we're going to find the dot product of u and v, and we know that if the dot product is 0, well, the two vectors are orthogonal, and if the dot product's not 0, then the two vectors are not orthogonal. So let's go ahead and let's find the dot product of u with v. So this is going to be our vector u, which is -12, 6, 15. And we're dotting this with our vector v, which is 8, -4, -10. Now the dot product is going to be -12 times 8 plus 6 times -4 plus 15 times -10. Well, let's go ahead and use a calculator to find this dot product. So we see that this is equal to -270, which is clearly not equal to 0. So what this tells us is that these two vectors are not orthogonal. Now for the next part of this problem, we want to determine, are these two vectors parallel? Well, in order to see that two vectors are parallel, or in order to show that two vectors are parallel, we need to find some constant s, so that u is equal to some constant or scalar s times the vector v. So there's a couple different ways that we could think about doing this, and if you look at these two vectors, you can almost see that there will be some constant s. So what I like to do is I like to just start with the first component of u. In this case is -12. And I like to just try to find a potential value for s. So let's set this equal to s times what's in the first component of v, which is 8. Now here, we can solve for s by dividing both sides of this equation by 8. So we have s is equal to -12 divided by 8, which simplifies to -3 halves. So here we have a potential s value. Now if we want to show that this s value actually satisfies this, we'll also have to check the next two components for both u and v. So since we want to multiply the values in v to get the values in u, let's take the second component in v, which is -4. We'll multiply -4 by s, which will be -4 times -3 halves, which is 6. And just by looking at u, we see that if we multiply -4 by our s value, we should get 6, which we do. So this s value works in our second component also. Now finally, let's go ahead and let's look at our third component. We'll take -10 from v. And we'll multiply -10 by our s value. So we're looking for -10 times -3 halves, which is equal to 15. And now if we look back at our vector u, well, we see the third component in u is 15. So what we have is we have u is equal to our s value, -3 halves, times our vector v. And what this means is that our two vectors u and v are parallel. Thank you.